So today's daily question 752. Open the lock. You have a lock in front of you with 4 circular wheels. Each wheel has 10 slots. Let 1, 2, 3, 4, 5, 6, 7, 8, 9. The wheels can rotate freely and wrap around. For example, we can turn 9 to be 0 or 0 to be 9. Each move consists of turning one wheel, one slot. The lock initially starts at 0000, a string representing the state of the 4 wheels. You are given a list of dead ends, meaning the lock displays any of these. If the lock displays any of these codes, the wheel of the lock will stop turning and you will be unable to open it. Given a target representing the value of the wheels that will unlock the lock. Return the minimum total number of turns required to open the lock, or -1 if it is impossible. If it is impossible, -1. You cannot reach the target without getting stuck. Eight. Because if we change any bit, we will get 8889 or 8887. Yeah, any bit. So this is impossible. We will get stuck. We will get stuck. This is just a BFS, very simple. Or we can do some optimization, such as search from both sides. I have written it before. Open the locks. Four digits, and every digit have 10 states. We will push the original string to now Q, and pop out all the elements in the queue for one layer, and then the second layer, and use a viz to remember all the visited nodes, and then when we find the target at some layer, then we return the depth of current layer. Yeah. Or if we cannot find the target, then we return the -1. Means that we cannot reach the target without getting stuck. We start from 40, and we use the unordered set viz to identify if current node is visited, and we set the dead ends to the viz to avoid getting into some invalid nodes. This is just a tree, multiple tree. Yeah, every layer have every node have 10 sounds, and every sound still have 10 grand sound. So the data extends very fast, grow up very fast. The memory both memory and both space cost and time cost will be very. If this is only 4 bits, if we grow one bit, then it will be very expensive, the cost. Then we get a current node. If current equals target, we just return. And after this layer, we add the layer. If the current node is invisited, then we just return. We just continue. And we set the current node to visited. Then we get the neighbors of current node. We move one bit, we can get two sets, such as this 8, 8, 8, 8. We move this bit, we will get 7, 8, 8, 8 or 9, 8, 8, 8. Or we can use the this will not overflow. To avoid the warning. Then we set the current but if current equals if pre equals 9, then we add 1, we are overflow. Then we set it to 0. So now we just check the width. If it is valid, is not visited or not dead ends, then we just push it to our next layer. Then we set -1. And if it is 0, then it will the count bit will overflow. We set to 9. If it is valid, not visited, then we just push to our next layer. Then we revert the current back for next bit usage. And after this layer, we add the return value. This can be changed to depth. or layer or somewhat. Yeah, it is the layer's depth, just as this. If the root is target, if the root of the tree is target, then we just return 0. If it is in this layer, we return 1. In this layer, we return 2. In this layer, we return 3. Yes, we just need 3 steps to reach this state. This is not difficult to solve in this way. Something got wrong. We should not return depth here, because when the code reach here, it means the target is not accessible. We need to return -1. Okay, so just solve it. Not very hard to solve in this way. There are many optimization because this is a search algorithm. Search algorithm can be optimized in many ways. First, we can optimize it in C++ language layer. We can use a char bit and we change every char here and use this integer value as a compare to check here. This will speed up now code, but not a very large percent. Have a test. Oh, and our submission about for 30%, somewhat faster. But there are still other optimization. We can, as the road, the tree grows, increases very fast. We can search from both sides, because suppose the depth of the tree is very large. Suppose it is 7, then the triangle, the area of this will be very, very large. But if we search from both sides, the area of the nodes we accessed will be almost half. All this area and this area will not be accessed. Many nodes are omitted. And there are still some other more smart algorithms, such as A*, to search directly, go directly to the target if there is no obstacle in the road. And if there are some obstacle, then just go near it. if you are interested, you can find some star algorithm and optimize this. It's in the midnight. I will not optimize this. Thanks very much. Time complexity. This problem, this question, the time complexity is there are 4 digits, and every digit have 10 states. And for every, this is the nodes of all the full tree, and we may access these nodes, and some nodes may be optimized because of the dead ends, and all its subtree is optimized, is not accessed, such as this. The growth of the time and space cost is very expensive because every node have 10 child. Yes. And for each node we have to 4 times. And to compare. This is 4 times, and for this one, this is the cost. Time. Yeah. And space complexity. Each time there are only one layer in the queue, but the visited may be very large. Every node is put into the visited after when we get to the last element, right most leaf. And this is less than this, so every layer's element is less than the whole tree. So this is, we will need to add something, and I will not add it right here about it. One layer, most element count. About this. Okay, so this is the daily question. Thanks very much.